Today, we're exploring the fascinating world of construction materials, with a special focus on rebar, or most would call it reinforcing bar. If you've ever seen or been to a construction site, those long, sturdy steel rods used to strengthen concrete structures wouldn't escape your eyes. Have you ever wondered how rebar is made? How big it is makes it quite interesting wanting to know about it. In this video, we'll take you through the entire process of rebar production, from raw materials to the finished product, and highlight its role in construction. Before we dive into its manufacturing process, let's get to know about this material we call rebar and why it's indispensable in construction. Rebar is a steel bar or a mesh of steel wires used as a tension device in reinforced concrete and masonry. You know, concrete is naturally strong under compression, but it's very weak under tension, meaning that small hit on a concrete house that's made without rebar could give a lot of news company juicy stories. But by embedding rebar, engineers create structures that are more resilient to forces like earthquakes, heavy loads, and weather conditions. Rebar comes in various sizes and grades, often featuring ridges to improve its bond with concrete. But we aren't going too deep into that aspect. Rather, we are talking about how it's made. Let's take a closer look. The primary ingredient for rebar is steel, typically derived from iron ore. The process begins with iron ore extraction, followed by refining to produce molten iron. This molten iron is then combined with elements like carbon, manganese, and silicon to form steel, with the composition varying based on the application. Generally, rebar steel contains 0.2% to 0.6% carbon. To make steel, two methods could be used, either the BOF or EOF, the basic oxygen furnace, short for BOF. In this method, molten iron is converted to steel by blowing oxygen through it to remove impurities. Pure oxygen is blown into the molten iron at high pressure, oxidizing impurities like carbon, silicon, and phosphorus, which are removed as gas or slag. The intense heat from the oxidation reactions raises the temperature, while alloying elements can be added to achieve specific steel grades. Once the impurities are removed, the steel is poured into molds or prepared for further processing. And secondly is the electric arc furnace, EAF. This process melts recycled steel scrap using electricity, offering a more environmentally friendly alternative. High-powered electric arcs, generated between graphite electrodes and the scrap, produce intense heat to melt the steel. During the process, impurities are removed, and alloying elements can be added to achieve desired steel grades. The molten steel is then refined, poured into molds, or further processed into billets or slabs. Now, shaping rebar. Once steel is made, it's cast into slabs or billets, which are heated to about 1,100 to 1,200 degrees Celsius in a furnace. These billets are passed through rolling mills to shape and elongate them into rebar. The rolling process not only forms the rebar, but also strengthens it through deformation, known as work hardening. After rolling, the rebar undergoes quenching, a rapid cooling process that enhances its strength and durability. It's then cut to standard lengths, typically 6 to 12 meters, and treated to improve its bond with concrete. The surface of rebar often features ridges or deformations to increase its grip with concrete. Methods like cold working or shot blasting enhance this texture. Additionally, rebar may be coated with materials like epoxy, zinc, or plastic to resist corrosion, especially in moisture-prone environments. Throughout production, rebar undergoes stringent quality tests for tensile strength, bending, and chemical composition. Reputable manufacturers comply with standards set by organizations like ASM International and the American Concrete Institute, ACI, to ensure reliability. Rebar serves as the backbone of reinforced concrete structures, providing tensile strength to support heavy loads and withstand dynamic forces. Whether in bridges, buildings, or infrastructure, rebar enhances structural integrity, safety, and longevity. Its use also enables more efficient material design, allowing for lighter and thinner concrete sections without compromising strength. The production of rebar is a remarkable blend of raw materials, advanced manufacturing, and rigorous quality control. From iron ore extraction to rolling and treatment, every step ensures a strong and durable product that is vital to modern construction. Thank you for watching. Don't forget to like and subscribe to our channel for more interesting videos on how it is made and why it happens. We got other interesting videos for you. Click the left or right video and enjoy.